And so we got to the question number 6, which is draw a line 7 centimeters long, construct the perpendicular bisector of the line, and then label the midpoint of this line M. I'm going to use my app again, which has a compass and a ruler. And I think I can place the question here. Yeah, just keep it here. Maybe on this side. Okay, so 7 centimeters. This part is easy. Draw a line 7 centimeters long. This is our 7 centimeters long. And construct the perpendicular bisector of the line. This is more interesting. So to do this, to construct the perpendicular bisector, we have to use the compass. And on the compass, we have to measure it to be a little bit more than half of this line. It can be actually the same as the size of this line, but this way the arc is going to be a little bit long. So try to make it just a bit more than half. Okay, and what we have to do now is we have to draw an arc like this. And then, without changing anything about compass, do not change the length of compass. Just move it and place it here on another end of this line. And then let's go like this. Okay, so now that we have these two arcs, we have to label the points of intersection of these arcs. And through these points of intersection, of these two arcs, we can draw a perpendicular bisector of the line. So this is it. This is a perpendicular bisector. Oh, I will write it again. Bisector. Perpendicular bisector. Again, the line is this. This is our line. Right, it's 7 centimeters long. Perpendicular means it's 90 degrees in relationship to the line. So this is 90 degrees. And bisector, it means that it cuts this line in half. Like this. The next part of the question, is label the midpoint of a line M. Okay, so how do we find the midpoint? Well, we already cut the line in half, so it means that the middle of this line is something we already have. And the middle of this line is here, because this is half and this is another half. So the middle of this line is here. And this is going to be our midpoint, which we will call M. So this is M. Okay, question number 6. We are done with you. Okay, next one. Oops. I think I will clean it. Draw an angle of 58 degrees. Bisect the angle using only a pencil and compasses. Alright, again we have to go to my drawing app. Bisect the angle using only a pencil and compasses. Okay, sure. Draw an angle of 58 degrees. So to draw this angle, we have to use a protractor. How to use a protractor? I think you guys did it already. If you're year 8 or year 7, you probably used the protractor before. But anyway, this is how you use it. So you draw a line, any length, not too long, not too short. And then you place a protractor. You place this part, this crest, you place it on the beginning of your line, here, like this. And then we have to find 58 degrees. So there's actually two ways to do this, right? 58 can be here, right? And there's 58 around here. So we should think about it. Okay, if you draw a line here, this is going to be acute angle, and we know that 58 is acute, right? So if we draw this one, this is probably going to be a bit too much. This is not what we need. So we should use another 58. So what we do is we take, normally if you would have a protractor, you can just mark it here. You can just mark this line, 58 degrees. Then you take the protractor away, and with help of your ruler, like this, you can draw this line. Okay, and this is going to be 58 degrees. Okay, now we have to construct a bisector of an angle. So to do this, again, we will need to use a compass. I think our compass, oh my god, I have so much tools on here. Let's clean it up. A bisector of an angle. So what we have to do, again, we take a compass, and let's watch this carefully. You choose any length of compass, anything up to you, not too long again. Don't make it longer than your angle. And so what you do, you draw an arc like this. You draw an arc here. And then, okay, this is important. You go to this point, one of the intersections of this arc and the angle. You go to this point, you draw another arc. And then you go to this point, and you draw one more. Okay, here, at the intersection of the second and third arc, you have to put the point. And if we draw a line for this point, like this line is going to be our bisector. So this is, oops, let me try this. This is bisector of an angle. All right, that was question 7. This is question 7. What else do we have? Construct the triangle ABC, where AB is 4.5, BC is 6, and AC is 7.5 centimeters. Well, let's do this. All right, I'm gonna take a screenshot. So number 8. AB is 4.5, BC is 6, BC is 6 centimeters, and AC is 7.5 centimeters. Okay, let's do it. So again, normally if we have only sides, we start with the longest one. So we draw AC. Okay, let's do a small sketch of this triangle also. Maybe it will help. So A, B, C, like this. A, B, C. AB is 4.5, BC is 6, AC is 7.5 centimeters. Okay, let's go. It's done. 7.5 centimeters. 7.5. This is AC. Then, of course, we take a compass. Oops, why is it not working right? We take a compass, we measure, what is next one? Next one is 4.5. AB is 4.5. So we measure 4.5 centimeters. We draw an arc here, like this. And then BC is 6 centimeters, right? So we can measure 6 on the compass, and we have to draw an arc from here. Go like this. Wow, this is a strange arc, to be honest. You see, it's like Yeah, not a lot of polygons in this arc. Anyways, this is our point. This is our point B. This is our point B, and this is going to be AB, and this is going to be BC. What kind of triangle is this? They're asking us. Well, it looks like a right-angled triangle. This is a right-angled triangle, ABC. So I think this is what we should mention as well. So again, wait, let me find the question. What sort of triangle have you constructed? What is a special name for side AC in this triangle? Okay, what is a special name for side AC? The side AC is called hypotenuse. This is a right-angled triangle, and AC is called hypotenuse. Okay, let me organize this a little bit. I hope people can read my handwriting. I'm really hoping for that. Okay, so last time I think I have to take all these screenshots. Yeah. So this is a line 7 centimeter long, and we have that. And now this is a triangle. This was number 7. Oh, sorry, this is number 8 already, so we have number 7 somewhere here. Draw an angle and then bisect this angle. This is bisection of angle. And then number 8 we have this. AC is hypotenuse. So this is part C, this is part B. All right, so 7, we go 6, 7, 8. Let's do a couple more questions. I think we can finish this chapter in this lesson. So a net. Okay, this is an interesting topic, number 9. Draw the nets of these shapes, constructing triangles when with compasses where necessary. I think I'm gonna cut it now. Constructing triangles with compasses when necessary. Okay, nets. This topic requires further explanation, so I think I'll do that. And also we will need another page for nets. Okay, yeah, this should be fine. So nets, I found this excellent resource which explains a little bit how the nets work. So nets, if you think about it, nets are those 3D shapes which are reconstructed to the form of 2D shapes. Again, this lesson was not made by me, so the credit goes to these people. There's a lot of them. They made this excellent lesson, which I'm very thankful for. So let's take a look at it. So this is a net of a cube. So let's see how it works like. We can close it like this and then open again like this. This is a net of a cube, and there's many ways to do a net of a cube. You can see that there's many different patterns. So we can do it like this also. Or we can do it like this. Many different ways to do a net of a cube. So this is a cube, and this is a net of a prism. Let's also do it. We can rotate it around a little bit. Rectangular prism, basically a box. Maybe you've seen those in the cutouts. There are books where you can cut out the shape of something and then put it together. This is what nets are about. Okay, so let's try to unfold this one. Let's fold it back together like this, and we can rotate it around. We can zoom it, I think, as well. Yeah, this is a net of a rectangle. Here we have a hexagon, but this is already an assignment. Okay, so assignments are in the book. We will do the assignments from the book. Okay, so let's do the net of this first shape. So first we have, what we have first is we have this kind of a triangular prism. Let's do it. Okay, I think I will have to keep it for a reference. I will have to keep it here for a reference. Okay, so we have this. So here you have to kind of use your imagination and your geometric, your spatial thinking, I would say. Let's try to do this. So what we have here is we have three rectangles, right? This base is a rectangle, and also this one is a rectangle, and another one. So this is three rectangles. We can draw them already. So what's important, I think I'm going to start with this one on the back. I'm going to draw this rectangle. So 7 and 3 centimeters. Again, they want us, so this is in this assignment we have to construct it accurately, so we have to actually use these measurements. So 7, 3, let's use it. 7, 3, I'm going to leave some space. 7 centimeters, and then 3 centimeters for this rectangle, like this. And then I think I can just go like that. Yeah. Again, 7 centimeters here, and 3 centimeters here. There is almost always, there is many ways to construct a net, actually. So here we have to, what we can do is we can use, you see those sides which are triangles, we can already put them next to this side, or we can put them next to the other side as well. It's really up to you. So I will put them here. Let me do it. So there is I'm gonna draw this side. I'm gonna draw this side. It's 4 centimeters. So here we have to use the compass actually. So we have 3 centimeter side, and here it's going to be 4. So let's use this. It has to be 4 centimeters. And this one has to be 5 centimeters. Let's make it 5. So it goes like this. 4 centimeters. Oh, sorry, this is actually 5 centimeters. This is 5 centimeters, and this is 4 centimeters. It goes like this. It's getting dark in my room already. And then we also have to do this to another side. Also 5, 4. So we start with 4 again, go here. And we get to 5. Go here. Like this. Again, we have 5 centimeters and 4 centimeters. Okay, the rest should be easier. Now we have to do, all we have to do now is we have to construct the 2 remaining rectangles, which is this one, this rectangle, and also this rectangle. We have to construct them. So another one, I think we have to go from the, we have to do this one next. So it's 7, 4, 7, 4. We already have 4. We already have 7. Sorry, we don't have to do 7, but we have to do 4. Why is it not working right? My God, such a mess. Such a mess that I made here. So this should be 4 centimeters here, and then 7 is already, it's already 7, and it's gonna be like this, something like this. And the last one is 5. So next one should be 5 centimeters. We barely have enough space. This is 5 centimeters. Okay, and this is it. This is our net. I think I'm gonna leave the construction parts. I'm gonna leave them untouched. This is 5 centimeters. 5 centimeters. This is 4 centimeters, and this is of course 7 centimeters as well. This is our net of this shape. Okay, let's make a screenshot. I think I will head to the next question because it takes quite some time. But if you have time, ladies and gentlemen, so what you can do is you can pause this video, you can take a screenshot for yourself, and you can try to do B or C as a homework for a better understanding of this topic, to practice, or as a homework can be your assignment. Okay, so this is A. This is how we construct it. Okay, let's do, what else do we have? Let me make it full screen. Finally. Okay, oh, this is a good question. This actually, I've seen this question in IGCSE papers. Somehow it also made its way to checkpoint books, which is the books we are studying right now. Interesting. So which quadrilateral am I? I have 4 lines of symmetry. I think I'm going to copy this question and let's do it together. Which quadrilateral am I? Again, quadrilateral is a shape which has 4 sides. I have 4 lines of symmetry. We have that one. We have that one. We did that on last lesson, right? Remember the square. Square has 4 lines of symmetry. So A is a square. I have 1 line of symmetry. My diagonals are not equal in length. Okay, maybe it's also there. My diagonals are not equal in length. One line of symmetry. This is a kite. This is going to be a kite, of course. 1 line of symmetry. You see, this is a line of symmetry, and diagonals are not equal in length. So this is kite. And in C, I have 2 lines of symmetry. My diagonals are equal in length. I think this is a rectangle. I have 2 lines of symmetry. My diagonals are equal. Yes, this is definitely a rectangle. But I feel like there should be some other shape which also has these properties. So you guys can try this if you want to. It'll be a challenge for you. This is a rectangle. Okay, so this was number 10. Let's do a couple more of them. What else do we have? Describe as many properties as you can of a parallelogram. All right. Whoops. Include rotational symmetry, lines of symmetry, and diagonals among the properties you consider. Okay, rotational symmetry of parallelogram. So what is rotational symmetry? Let me try to show this to you. First I have to draw the parallelogram. Let's say this is our parallelogram. So rotational symmetry is basically how many times the shape is going to fit itself when we rotate it. So we start. When we start, it's already 1 time. Let me try this again. So, okay, so when we start, it's already one time, and then we go clockwise. We start rotating it. It's gonna fit itself here, like this. It's gonna fit itself. So that's already 2 times. And then we come back to the original position. So rotational symmetry is 2. So first, we can say order of rotational symmetry equals to 2. Lines of symmetry, so as I said before, as I told you on lesson 3, we can go back to this table. Parallelogram has 0 lines of symmetry. There is nothing, no symmetry whatsoever. 0 lines of symmetry. And diagonals. So diagonals, again, another property that is good to remember, to memorize. Diagonals bisect each other for parallelogram. Bisect each other. In other properties, we can say that there's 2 pairs of parallel sides, and also there's 2 pairs of equal sides as well. This is properties of parallelogram. I hope I didn't forget anything. If I did, you can let me know in the comments. That would be really nice. Okay, see you guys next time.